Welcome back to a tutorial. Today we're looking at a very interesting example. We're looking at a summation of a very unique series. So when we zoom in and we look at this, let me just double check the styling's right. So we have the sum from r equals 1 to n, it's not the clearest drawing, I apologise, of cosine of r, let's see, r of x, like that. So, basically it's in this form here where it's cos of x plus cos of 2x plus etc. all the way until cosine of n of x. Now the thing is, with these examples, it's very common when you think of this to get it into the exponential form for cosine of x. That'll be the initial thinking that you might go for. That's probably the most popular way of doing it, but you can do it with other ways. You can use the method of differences. You don't have to use that. Again, the common identity that people use is that cosine of r of x would be equal to e to the power of I r x plus e to the power of minus I r x. That would be the most common way of doing it potentially. However, we can use the method of differences. There's important identities we want to look at in terms of trigonometry. The first main one we're going to look at is there's a product to some formulas, identities in trigonometry. We can look at cosine of A times by sine of B. So you've got two angles there, two different angles, is identical to a half times by sine of A plus B minus sine of A minus sine of A minus B, like this. This now is very important. We can actually use this formula here, this identity is going to be very useful in what we're doing, because with that you can see it's minusing things, and whenever you use method of differences you want to be minusing things like that in that sort of telescoping series way. Another important formula we can use for cleaning things up later potentially it comes from the same place, which is sine of x. X is a different angle, we'll assume it's any angle, plus sine of y is identical to, I'll just put it below it, 2 sine of x plus y over 2, not the neatest, I apologise, times by cosine of x minus y over 2, like this. Now these are actually very useful identities, and you can use them in a lot of examples. Whenever you have summing trigonometry, they can be very useful. I mean, let's go to this page here. It's pretty easier. So let's do now. If again we know the sort of that summation rule, what we can actually do is we can write it in this way here. So again, we knew it was half, so we know therefore that 2 sine of A cos of B, we're timesing it by the 2, both sides by 2 for the identity, is identical to sine of A plus B minus sine of A minus B. So we have it in this form here now for this series. Now, based on our formula here, we can actually put in here Rx, and we can put in here x for the angles. And therefore you'll have Rx plus x, and you'll have Rx minus x. And if you take out a factor, look at this fact, take out a factor of x, look what you have. You have r plus 1. And take out a factor there of x, r minus 1. And that's something we can actually work with. So we can rewrite that now here very clearly as 2 cosine of rx times by sine of x is equal to sine of r plus 1x, like this, and out of brackets as well, not very clear, I apologise, minus sine of r minus, like this. And what you have here is a method of differences, and that's fairly clear now. We have that method of differences formula that we can now apply to our example. It's been quite, let's go to the other side. Now, for this, we know that's the same thing as, we can rewrite it as 2 sine, of x. And we know, remember the sum, remember what S of n is. S of n is equal to, it's not very clear, is it? Of n is equal to the sum from r equals 1 to n. I'm really bad at drawing n, I apologise. To n for cosine of rx, like that. So therefore, 2 sine of x times by the sum of n, like that. The reason why sine x is like that is because it'll be sine x for every single one. So we don't have to have a different one. Since it's sine x for every single one, we don't have to worry about that. You know, it's going to be like sine of x cos of x plus sine of x. It should be 2, by the way. We'll take out a factor of 2. Sine of x cosine of 2x, you know, etc. That's the way you'd write it, really. We're taking out a factor of 2, but that's the way you'd write it, basically, in terms of having that. So with that in taking that into account, we can now make that equal to, let me see. Yes, basically you can make that equal to the sum from r equals 1 to n, not very good at n, I apologise, of 2 sine of x, because you've times it by 2 sine of x, times by cosine of rx. That's the form we have it in, and now we can actually work with it. See, sine x times by, 2 sine x times by s of n, the sum of n. Again, it's just going to be 2 sine x times by it. That's all it is. It's just 2 sine of x times by the cos of rx. That's the only difference you're making. And then we know that is going to be equivalent to, because of the product to sum formula, 2 sine of x times by sum of n is going to be equal to the sum of r equals 1 to n for 2 sine, again, it's that method of differences now. So sine of r plus 1 x, like that, minus sine of r minus 1 x, like this, into the final brackets there. We have that there now. See, now we have a method of differences, which is actually going to be very useful for us. The next part now, we can say, let us just get all the positive and negative terms. So we'll say sine, we know it's going to be sine x cos of x, like that. We won't include the 2 sine x, because everything is multiplied by 2 sine x. And also, no, we don't need to, because it's the method of differences now. We're now looking at these here. So let us go back and just do what we know for r equals 1 is going to be sine of r plus 1, which is 1 plus 1, which is going to be sine of 2x. For r equals 2 is going to be 2 plus 1, which is going to be sine of 3x. And then you're going to, and then 4x, and then 5x, and so on. And it's going to go all the way until it reaches sine of n plus 1x. As at n is going to be r plus 1, n plus 1, sine of n plus 1x, like that. And we're going to also look at all the negative terms. That's the positive terms. The negative terms was r minus 1, isn't it? So it's going to be r, again, 1 minus 1 is 0, so sine of 0x. And then 2, 2 minus 1 is going to be sine of x. And then we're going to have 3 minus 1, sine of 2x. And you're going to go all the way until you reach the last one, which is going to be n, or n minus 1. So it's going to be sine of n minus 1x. Of n minus 1 x. Not very clear, that x. Now what we have here, the two sets. We have the positive numbers, the positive ones here, and we have the negative ones here. And basically things are going to cancel out. We can see straight away that 2x, that sine 2x is going to cancel out. Sine 3x will cancel out with something further down the line. Sine 4x will cancel out. And you'll keep going. And then what we're going to be left with, as you can see, since the last term is sine of n minus 1x, that is going to cancel out with something in the positive like that. However, sine of nx, there is no negative sine of nx. Do you know what I mean? We don't see that. And there is no negative sine of n plus 1. So therefore, you're going to be left with terms, this one, and sine of n plus 1x, and sine of nx, as there is no negative sine of x. It ends at n minus 1. So with that in mind, you're going to rewrite the whole formula, and you're going to have the final form as sine. This is what basically the terms you're going to have left are going to be sine of n plus 1x, n plus 1x, add sine of nx, like that, minus sine of x, because then remember the negative terms, sine of nx, and minus sine of 0x. Well, we know straight away that sine of 0x is just going to be sine of 0, which is 0. And remember the formula that we had it in. We had it in 2 sine of x sum. So we had it like this. It was in this form, remember, 2 sine of x times by sum of n, like this, is going to equal these terms. Remember that this part here is just 0, as it's just sine of 0, which is 0. It's going to equal sine of n plus 1 x. Again, not the clearest, I apologize. Add sine of nx, like this, and minus sine of x. So now I've got it into this format here. So you can see you've got all the terms now. 2 sine of x 2 sine of x times by the sum of n is equal to sine of n plus 1x. Add sine of nx minus sine x. And with that, we just divide both sides by 2 sine of x to get it into a final form, at least an initial final form. Sum of n from, 1 to n is equal to sine of n plus 1 x plus sine of nx minus sine of x is all over 2 sine of x. So you see now we have it in this formula. We have a first initial summation formula of it. That is the sum from r equals 1 to n. However, we can clean it up a bit. We can make it a bit better. We basically want to break it down into as few terms as possible, if possible. That's a bit messy, although it'll work. You can put your numbers in, it will work. However, we want to get into a better formula than that. And we're going to use a rule. Basically, from that sum to product rule we had earlier, if you remember it, I'll just scroll to it. The one that we want to look at, it was this one, sine of x, y. Sine of x plus sine of y equals 2 sine of x plus y over 2 times by cosine of x minus y over 2. And that's the one we want to use, basically. So the next part this is what we do. We are going to, as you can see, it's sine of n plus 1x plus sine of nx, these two terms. And basically it's going to be, we know it's sine of n plus 1 x plus sine of x, sine of nx, like this, is identical. We'll say equal. We'll say identical. Is identical to, and we add them up to 2 sine of, now n is going to be n plus 1 plus n is going to be 2n plus 1. Since they've both got a factor of x in it, it's going to be 2n plus 1 when you add them. So it's going to be, let's see, sine of 2n plus 1 over 2. Yeah, you have to divide the whole thing by 2, remember? Like that. And times by cosine, and it's going to be n plus 1 minus n, which is going to be n plus 1. Look, n plus 1 minus n is just going to be x, because n plus 1 x minus n x is going to equal x. So it's going to be cosine of x over 2. which is useful, and that's useful now. We have that into that format. I'm also going to do one more thing. We're going to do the same thing for basically sine of x. Now this is interesting. Basically, we can actually rewrite sine of x in quite an interesting form. Basically, you can write it like this: sine of x plus over 2 plus x over 2 and it's going to be rewritten as minus sine of x over 2 minus x over 2, like that. And we know from identities that that's going to be equal to, we know from identities, remember you have a and b, so we can rewrite that as basically into this format. 2 sine of x over 2, like that, times by cosine of x over 2. And now, interestingly, in this formula we know that sine of x over 2 plus x over 2 is going to be sine of x, just sine of x. And then we know that sine of x over 2 minus that sine over x over 2 is going to be sine of 0, which is just 0. So you get it into sine x. So therefore we have it into this form here. So you can get into a final form of this. So we have the sum of n is equal to, again you get into this format of, we'll basically plug in what we just got before. Put a bit lower to make it simpler. So the sum, the sum of n, again from 1 to n, is going to equal, we can get into this formula here, let me just write it out. So it's going to be 2 sine of 2n plus 1, like this, 2n plus 1 over 2 times by x, and the outer brackets, like that. And you're going to have that times by cosine of x over 2. And then minus, and remember it was sine of x, remember, as you can see from before, it was sine of x. In that formula, you can see it there. See, sine of x and sine of x. So, again, it's going to be 2 sine of x. And it's going to be that identity we had before. So 2 sine of x over 2, like that. Cosine, cosine of x over 2, like this. And that's all going to be over the long fraction here. It's going to be a very long fraction over, and remember it's 2 sine of cosine, and remember we had it over 2 sine, however we had it over 2 sine of x before, however it's going to be sine x is identical to 2 sine of x over 2 cosine x over 2, so 2 times by 2 is 4, so you can have it over 4 sine of x over 2 cosine of x over 2, like that. And we get into that format there. And now what we can finally do is we can actually cancel things out. So we can cancel x out over 2, see? That's going to cancel out. That's going to cancel out. And we also know that the 2 is going to cancel out, like that. That's going to become 2. That's a really bad drawing, I apologise. Like that. And we have it in this final format now, this final formula. And to actually write it in the final form, we can write it as the sum of n, which is equal to the sum from r equals 1 to n of, that's not very clear, to n of cosine of rx of rx at that is equal to, and the final formula we have, which is going to be, after we've cancelled everything out, it's going to be sine of 2n plus 1 over 2, like that, times by x, in a bracket like that. Not the clearest, but you see what I mean. Times, and I mean, there's no times by cox anymore. Minus sine of x over 2, like that. And it's going to be all over 2 sine of x over 2. Yeah, and that is the final form. That is the final form. As you can see it there. The sum, so we can write it, we can just look at this here. The sum from 1 to n of cosine of Rx is equal to this. And this is the final format. This is the final format we have it in. But yeah, thanks for watching, and please consider subscribing. Thank you. Bye.